Hello student, today we are going to study class 9 chemistry chapter matter in our surrounding. Okay, in this chapter we will study what is matter, what are the classification of matters, how to describe a matters, and what are the types of matter we have. Okay, so each and everything we are going to discuss here. So let's continue with this. The first thing is what is matter. So if you let's try to understand what is matter. So what the first thing that come in your mind, like if you have to like look around you. Okay, so when you will look around you, you will observe that okay, there is a table, there is a chair, there is a bed, there is a door, there is a fan. So everything you will see around you. So that all things are what matter only. Why this is all the matters? Because if you see the definition of the matters, what is the matter? Matter is anything that has mass and occupies space. So if you see, suppose this pen is an object, okay? So it will obviously have some masses, right? So if it has some mass and occupies space, obviously if you keep somewhere, then it will occupy some spaces, right? So that space will be occupied. So you can say that this has some mass and it is occupying space, means this is what that is called as a matter. Okay, so I hope you understand what is matter. So if you see the example of the matter, what will be the matters examples? The first is, suppose you can write like pen is example, chair, okay, and table. So anything you see around a matter. Sir, yesterday in my class I have fight with my friend and it become a matter. Is this a matter? No, it's not. That is not a matter because you have fight. That does not have any masses and that does not have like occupying space. So it will not consider as what matter. Okay. So I hope you got an idea what is matter. Okay. So let's try to understand. So if we see the classification of matter, so what is the classification of matters we have? Suppose if we see the physical classification, physical. So physically classification we have three types of matters. First one is solid, liquid and gases. Okay. If we see the chemical compositions, like you can write like composition, chemical composition if you see. So on the basis of chemical compositions we have how many types of matters? Pure substances, okay, and second one is mixtures. Fine. So these are all like classification of matters we have. Okay, the first on the physical compositions we have solid, liquid, gas. On the chemical compositions we have pure substances and mixtures. Okay, I hope you understand what is solid, liquid, gas and what is pure substances. So if we we will discuss solid, liquid, gas each and like one by one. Let's discuss like pure substances. Suppose if you are adding one chemical, so this is like pure only that chemical. Like suppose if you are taking any chemicals that you have around you. Okay, so if it is a pure only. But if you are mixing with some other chemical, so it will become what? Mixtures only, right? So that is also matter and the pure one is also matter. But they having a different like compositions, okay? That is they have a different name. Like the one is having a pure substances, other one is as a mixtures. So this is what the classification of matters we have on the basis of what? Chemical compositions. Okay, so this is a chemical composition classifications. We will see what is solid, liquid, gas. Okay, so you can see that like here we have a like three diagram. You can see here we have the first one is a solid, okay, and this is a liquid and this is a gas. Sir, how you can say this is a solid? Actually, like suppose this pen. Let's understand with the pen. So if you see the part like this like pen is made up of what? Matters like particles. Okay, so if you see that these all are the particles of like matters that we have by which this pen is made, right? So if you open this like diagram, like if you see this like how the pen is made, so this is the what actual diagram you will observe here, right? So you can see that there are a lot of particles by which this matter, the solid is made up of. Okay, so like you can understand. So by this diagram only we can understand what are the like properties of solid that will show. Okay, we will discuss this thing also. So as of now, just understand this. This is a matter of like which of kind of solid kind of matters, and it's look like this. Why? How it look like this? What is the what are the conclusion we can take out from there? So each and everything we will discuss. Okay, so don't worry. So this is the liquid particles. Suppose if you see that these are the liquid matter. Suppose if you see water is also a matter only, right? Because it has some masses and occupies space. So this is the second classification of liquid. Okay, and the third one is gases. Okay, so this is like all are three different kind of matter that you have. Okay, I hope you understand. So we will come to this diagram again. Let's discuss for this. Yeah, physical nature of matter. So if you have a matter, so what is the physical nature that matter shows? Okay, so we will discuss this thing each and everything one by one. So let's start with the first one. So if you see this, the first point say that matter is made up of particles only. Okay, so what is matter is made up of particles? Let's understand these things. So I already said you that, like, suppose if you see this pen with the microscope, there will be a lot of like small particles by which that pen is made up of. Okay, so this is what I was saying. So all these small balls that you are seeing, that these all are what particles only, small particles. Okay, by which the, like, when you are combining all the particles, it will become what? Solid. Suppose if you see the tables is made up of small particles. So everything that solid you see, it is made up of small particles. Okay, I hope you understand what I'm saying. So let's so that this is the first point is clear. I hope it is clear to you that matter is made up of what? Particles. Okay, if we see the second point, matter particles of matter have space between them. Okay, let's try to understand this. Okay, if you see the diagram, you can observe that, like, every particles, in between that we have a space between them, right? So we can see this, like this dot you can see. So whenever you will attach two particles, what will happen? There will be a gap will be formed, and that there is obvious, like, definitely there will be a space between them. Okay, so that is what that second physical properties are saying, that particles of matter have a space between them. Okay, if you see the liquid particles also, what do you observe? There are the space between them. Every particles are having a space between them, right? So you can say that, and gases as well, we have a space. So every matter that you see, are made up of, first thing, that are made up of particles, and they have a space between them. Okay, I hope you understand what the second point of physical properties also. Okay, so let's continue with the third one. Particles of matter are continuously moving. Yes. Suppose if you see this, these particles, suppose that these are the gas particles. Okay. So if you, like, if you open the container, then what will happen? The gases particles will start moving. It's there and where. Okay. So this is what the nature of the matter of like physical nature of the matter we have. Okay. So it's not about the solid that particle of matter will start moving like that, but the gases and liquid, it will start moving. Okay, continuously moving. They are continuously moving. Okay. So the first thing. So let's discuss the third point. Fourth one. Particle of matter attract each other. Definitely, particle of matter will attract each other. Suppose these are not the particles of matter. So if it is not attracting each other, then is it able to look like this shape? No, because if it is not attracting each other, means it will break down. It will fall down. Suppose if you see in the school there is a chalk. Chalk are able to look like this, like this shape. Why? Because it is the particles of the chalk is what? Attracting each others. So this is the reason why they are look like that shape. Okay, I hope you understand all the like properties of physical nature of matters. Okay, so let's like recap this thing again. The first point that I have said, that matter is made up of particles. Obviously matter is made up of what? Particles only. The second point we have discussed, that particle of matter have space between them. Definitely particles of matter have space between them. Third point we discussed, like, particle of matter are continuously moving. Obviously, like gases particles, if you like suppose if you like burn incense stick. Okay, so what will happen? All the smell will go around in the room. Means the particle are moving there, and that's why it is able to move, right? So so we can say that, like, particles of matter are continuously moving. The fourth one is particle of matter attract each other. Obviously, like, if it is not attracting each other, then this is not possible to the shape that we want to see, that is not possible, right? Because of the particles are attracting each other, that is the reason why whatever the shape we are able to observe, that is we can see that. Okay, fine. So I hope you understand what are the physical nature of the matters. Okay, so we will do one thing. Let's try to yeah, we see, if you see this diagram, so all these are like shown here. So particles are like very small. So you can see that, like, suppose if you see with the microscope, then what you will observe, the particles are very small. Okay, so that is why you are able to see, it will, like, these are the particles, small particles. Okay, so you can see, like, by the microscope lenses, if you see, So you will able to observe the particle are very small. Okay, the next one is particles are continuously moving. Sorry, constantly moving. So obviously you can see that like these are all constantly moving. Okay, so there and the third one is a particle attract each others. Obviously, like these, you are able to look like this shape because they are attracting each others. So these all are the particles that are attracting each others. That is why you are able to see this, right? So like these balls are like attracting each others. Otherwise, you will not able to see the shape like this. If it is not attracting each other, it will look like different shape, right? You are not able to look like this shape. So that is why they are attracting each other. That is why they are looking like this shape. Okay. So okay. So we will do one thing. Let's try to understand the this all property by the activity only. Okay. So in the NCERT also they have given one activity. So let's try to understand. We will take like multiple beaker. Okay. This we have taken beaker one, and we will take some water here. Okay, like for, as of now we have taken only three and so on. Like we will take like 100 of beakers like this. Okay, so here we have taken 100 ml of water, 100 ml of water, 100 ml of water. Okay, these all are the water only. So what we are doing here is, so we will do one thing. We will add potassium permanganate here. Okay, potassium permanganate color is purple. Okay, pink and purple color you can say. So when you will like we have taken 10 gram of potassium permanganate. Okay, so we will take 10 gram of potassium permanganate here. What we will do, we will just put it in that beakers. So what you will observe here, let's try to understand this. So when you will put this into the table like beakers, what you will think like this color of this like the color of that it will start changes. Okay, it will start like started changing. Okay, so this color will change to the purple color. The water color is will change into purple color. So when you will put this into the like beaker, the color will be changed. So okay sir, so we are by this activity, first activity actions, we observe that what, that sir when we put 10 gram, it is able to mix like get like mixes. Again if you like suppose if initially you have labeled that that this is the level of water. Okay, initially 100 gram level was this only. Now when we added 10 gram also, then again we see that this is the only level of water. Why this? What is the reason behind that? Suppose we are having 100 ml of water and we are adding 10 gram another like another mass of some substance. So its level should increase, huh? But it is not increasing. Why? There is a reason behind that. What is the reason? The reason is because we have studied here. Particles of matter have a space between them. Because that water have space between them. That's why when we are adding 10 gram also, then again the level is not changing because they are having a space, because they are having, that's why it is the level is not changing, right? So I hope you understand what is the like first property. Okay, and again we will let's try to understand that. So what we will do again, we will again take 10 ml of this solution mixture and put it here. What we will do this, not 10 gram, we will take out 10 ml of this solution potassium permanganate water and we will mix into this. Again we will observe that this color will become what, purple. So we can see that, and again we will do this activity again 100 times. So again we will keep observing that that color are getting changed into purple. So by this activity we can observe that, sir, this 10 gram are having lot of small particles. That's why it is able to make it purple all the 100 like beakers, because it is the only one this much like substances, and it is able to make purple all the 100 beakers of water because it is having what, 100 like lot of small particles, right? So that is why it is happening. So this part like tiny particle is cleared here also. And also one thing more thing, like yeah, so space part is also cleared from these activities. So I hope you understand what is the activity is. So let's try to again discuss this thing. Like we are putting 10 gram in the water and we see that the color get changed to purple. Okay, so but and the level of water also not increased. So that the particle of water are having a space between them. That is why, because the level is not changing. And what we did, we taken out like 100 ml, sorry 10 ml from the beaker and keep doing this activity again and again to 100 beakers, and we observe that like all beakers get colored by the purple. So this kind like by this activity we can observe that like particles of that potassium permanganate, that 10 gram that we have taken, that is a very small, made up of very small particles, tiny particles. Okay, so by this activity we can observe the like properties of matters. Understand what are the properties of matter that shows. Okay, so I hope you understand this like activity. Okay, so let's try to okay, so this slide is already discussed. So let's try to discuss the like what are the properties of like each part of matter, like solid, liquid, gas, source. Okay, so let's try to discuss one by one. So the first properties that you can see here is definite shape and volume. Obviously, like the solid, if you observe, the solid are made up of what? You can't, that shape is not changed. Whatever the shape of the solid is, that will be the that shape only. It won't going to change it. Okay, so this is the first like property, that solid. So particles are closely packed. Obviously, that we have seen here that particles are what? Closely packed, because by the like previous diagram we have seen that like the particles are like this, right? If you see that, like this is the like part looks, this is how the solid particles look like, right? So if you see that, so like definite shape, obviously they are having a definite shape, the solid has having a definite shape. Second, particle are closely packed, so you can see that the particles are very close to each others. That is what the solid properties that is why the solid show this property. Okay, so strong intermolecular forces. Third point, what is strong intermolecular forces? Because this particles of the solids are attracting each other with very high forces. They are not able to easily break it, like able to easily break, right? So that is why we can say that the strong intermolecular forces we have. Okay, third is fixed position of particle, like they are having a fixed position, like whatever the position you observe here, that will be the fixed position only. Okay, the next one is they have a negligible compressibilities. Obviously, suppose if you have a solid, suppose this is a solid, right? So when you will compress this, it won't easy to compress this like easily, right? So you can say that this property will be shown by the what? Solids. Okay, I hope you understand what is the property that is shown by the solid. Okay, let's try to understand the for the liquid one. So we can say that the liquid, they have a no fixed shape but have fixed volume. Definitely, suppose if you are having a 1 liter of water, so they whatever the suppose the you have taken 2 3 different shape of beakers, whatever the which beaker you will put that water, they will take their shape only, because that the water does not have any shape. It will depend on the beaker shape. So you can say that liquid does not have fixed shape, they fix, but volume is fixed. Whatever the quantity you have taken, that water, that will be the fixed one. It won't going to change, but the shape will be take that depend on the container that we are taking. Okay, so I hope you understand these things. The next one is yeah, that is written also, that they take up the shape of the container they have taken, right? Particles move freely and have greater space between them. That is already we have discussed by the activity, that the water we have that it's look like this. So you can observe that the particle of water will be look like this. They are having a space between them. That is why we have mixed potassium permanganate and it was the level of was not increasing. Okay, so this is the reason behind that. Okay, so I hope you understand the properties of liquid. Let's come to the solid gases one. Okay, so for the gases one, if you see the particles look like this. So now by this diagram only you can observe that what are the difference between the particles of solid, liquid and gases we have. So the first one is they have no fixed shape. Definitely the gases particles will have no fixed shape, because it take whatever the whatever the like room. Suppose if you just open that gas, suppose if you open the beaker that contain gases, so what it will take the shape of that room only, right? So they don't have any fixed shape. The particles of gases have large space between them. Definitely the particles are like moving very freely and they are having a large space between them. The gases are high compressible compared to the solid liquid gas. Definitely the gases are very high compressible, like because they are having a high space between them, and if you, that is why we are able to compress that now. Suppose if you are not able to they don't have a space between them, large space between them, so is it possible to compress that? No. So that is what we have. Okay, this is what we have for the liquid gases one. So I hope you understand what are the property that is shown by the gases, liquid and uh, solids. Okay, so let's try to with the next slides. Okay, so okay, we understood what is gases, what is liquid, what is state. So what is the change of state of matter? Suppose we want to change from solid to liquid, liquid to gases. What are the way that we can do it? Okay, so let's try to understand this. Okay, so suppose we are having some solid object. Okay, so if you heat that object, it will convert it, may convert it into, not every like solid will convert it into a liquid one. It may convert it into what? Solid state. Okay, sorry, liquid state. And when you again heat the liquid state, it will go to that what state? Gaseous state. Okay, I'm not talking about the every liquid or solid that show that property. Okay, that the changes that we can observe. Okay, so if you like, let's come to the reverse one. So if you again started cooling that gaseous state, then it will give what? Liquid state. Okay, and if you start again like started cooling the liquid state, it will give what? Solid state. So this is how we can change the state of matters. Okay, so if you heat the solid, it will give the liquid one. If you heat the liquid, it will give the gases one. If you cool the gases, it will give the liquid one, and if you cool the liquid, it will give what? Gases one. That is why, like suppose if you like cool the water, it give what? Ice. Ice is a kind of solid. Okay, so this is the changes of state we can do this. State is what? Like solid, liquid, gas. That is a state. So these changes can be done by this activity. Okay, I hope you understand this. So let's understand what is written here. So the change of state of matter is when substances changes from one physical form to another without changing its chemical composition. So you can say that like you are doing, the state is changing, but the composition, the chemically whatever the like compound formula is, that will be the same only. It won't going to change. Okay, this is what you should understand that. Okay, so what is this? They are saying that we can change the state of matter without changing their what? Chemical compositions. So this is what we have. Okay, I hope you understand this. So let's try to understand for the next one. So what is diffusion? So diffusion is like a process, like when you intermix, like the things get intermixed with each other, right? Suppose if you see that by the diagram only. So this is a liquid. Okay, if you like when you put that some another substance, it get intermixed with each other. So this like it get diffused to each other. Okay, so you can say that like intermixing of substances is what? Diffusion only. Okay, suppose like let suppose you burn what incense stick and it get involved, it intermixed with the airs. So it is what? Diffusion only. Understand? I hope you got an idea about what is diffusion is. Okay. So intermixing of any two different kind of things, that will be what? Diffusion. This process is what called as what? Diffusions. Okay. So let's continue with the next thing. Melting. What is melting? So melting, what by the melting, what you can understand, like suppose if you like started what heating some state of matters, then what will form? It will start melting, right? So you can see this diagram like okay, yeah, by this diagram you can understand that like suppose this is an ice. Okay, so if you increase the temperature, if you increase the temperature of that ice, then what will happen? It will started melting. Okay, it will started like changing to what? So you're providing heat only, not that kind of heat. Like temperature is decreasing, like increasing means what? You're providing heat. Okay, so this process is what called as what? Melting only. So you can say that melting is a phenomena where solid heated, then particles begin to vibrate greater speed and begin to move more freely than the particular temperature solid melting to liquid. So simple way you can understand that when you will provide a heat to any solid, it will start melting and become what? Liquid. This process is called what? Liquid. Okay. So suppose melting point of ice is what? Suppose you have an ice and that it will be 0 degree Celsius. Okay. So we can say that 0 degree Celsius. Okay. So let's try to understand next point, interconversion of matter. Suppose we are having a three different kind of matter. Okay, so if we want to interconvert each and everything, like every part of matter, so then how we can do this? Let's try to understand this. Suppose you are having a solid. Okay, you are having a solid here. So what you will do? Suppose if you want to convert that solid into liquid, that is called what? That is called as a fusion. Okay, that is a melting that we already studied here. Okay, you can see here melting is also called as what? Fusion. Okay, so you can say that when the solid converted into liquid, this process is called fusion. Okay, and when the liquid converted into gases, this process is called vaporization. We will understand this thing. Okay, this process is called vaporizations. Okay, and when the gas is converted into the solid, this process is called sublimations. So we will understand each and everything. Just learn the process that when a solid converted into the gases, this is fusion, and with the liquid converted, solid converted into the liquid, it is fusion, and the liquid converted into the gases, it is vaporization, and when the gas is converted into the solid, it is what? Sublimations. Okay. So I hope you understand. Suppose let's understand by this way. Suppose solid be directly converted into what? Gases. Then again it is a process of what? Sublimation only. Okay. And if you convert again gases to what? Liquid, that is called condensation. And again the liquid converted to the solid, that is called solidification. So these are all are the process of interconversion of two state of matters. Okay. So you can understand that if you're converting from like solid to liquid, liquid to gas, or gas to this, these all are the process. Okay. So we will understand this process one by one. Let's understand this. So the first thing is boiling. Okay. Let's understand boiling. What do you mean by the boiling? Suppose you are having a 1 liter of water. Okay. You started heating this water. So what you will observe here? You will see that the temperature will start increasing by the equipment. You can observe that the temperature started increasing, and the molecules of water started boiling. Okay, so let's try to understand. When a liquid is heated, its particle begin to move even faster. So then the particle of temperature of liquid begin to boil and changes into gases, vapor. So let's try to understand by this diagram only. So suppose if you providing heat here, right? So it will start boiling. The particle, the smaller particle will go to the upper part, and this smaller particle will go, and the cooler particle, like this cooler particle will come down like that. This phenomena will keep happening, and after some time you will observe that this like the water molecule of water are becoming what? Vapors. Okay, so this process is called boiling. Okay, so you can understand this thing. So, and this boiling is what type of phenomena? Bulk phenomena, because there are not only like one molecule, one part of the molecule, like water molecule is boiling. Every part of that molecules are boiling. Okay, so we can say that this is called as what? Bulk phenomena. Okay, that's why we say that boiling is a bulk phenomena. So please remember this point as well. Okay, so let's try to understand the sublimation process. So we already have discussed that this is an interconversion of state of matters, right? So let's try to understand. So sublimation is like if we want to directly convert gases like solid into the gases, or gases into the solid, that process is called what? Sublimation. Okay, so let's try to understand this. The changes of state are directly from solid to gases, or gases to solid, is called as what? Sublimation. That is what we have already discussed this point. Okay, so I hope you understand this. Okay, so let's try to understand like how we can do like these things. So let's try to understand. This is a like camphor that we have taken. This is a burner that you have taken, and here you have taken some ammonium chloride. Okay, and this is a Chinese type of dish that you have taken here. So what will happen? Like ammonium chloride vapors will started when it was started boiling, the vapors will started coming here, right? So again we have taken here cotton, and this is the like process that we how we and here you can observe that the particle of the ammonium chloride has started solidifying here. So from this process, sublimation process, you can get like a solid to what we are taking, yeah, solid to gases, or uh, gases to solid here. Okay, okay, next thing is if the solid camphor or ammonium chloride is heated, the changes into vapor. If vapor are cooled, it changes into solid. Okay, like suppose if you are hitting that ammonium chloride, it will changes into the vapor first, and if you again started pulling that, it will come to the what solid part. So this is how we can interconvert. Okay, so this is what sublimations we have. Okay, next thing is evaporations. What is evaporations? I think you have already observed in your house. Like suppose you when you put your cloth in the rope, and after some time, by the help of sunlight, you see that cloth is like it was earlier wet, but it is now what very dry. So we can say that the process is what evaporation only. Okay, so let's understand this. How is evaporation happens? Okay, the change of liquid in vapor at any temperature below boiling point is called evaporations. So you can say that like in this process, you can see that like heat is providing by the other like factors like sunlight and all, but it is not coming to that boiling point level. Suppose you are not like suppose you put the cloth and it is not going to like started boiling, so it will evaporation is a below the boiling point. Okay, so this is the process you can understand here. The change of liquid in vapor at any temperature below boiling point is called what evaporation. So when you are changing liquid, suppose your like cloth was, suppose this is a particle of cloth. Okay, so when you provided the sunlight in here, the particles of that started what becoming vapors, right? So and it is started that particles of that cloth will start what drying. So this process is called evaporation. Okay, so what are the factors that affected by the evaporations? So rate of evaporations depend on the surface area. Obviously, like suppose you have taken like suppose you have taken two cloth, and like the surface area was this one, and the same cloth the surface area will decrease to this part this much time. So what will happen? This will start like this will get dry fast as compared to this cloth, because it is having what the surface area are like more than evaporation will start happening more, so it will become what it will start evaporating more as compared to this article. Okay, I hope you understand that. Temperature and humidity and wind speed. So what are the temperature you are providing, that also like matter. Like suppose you are providing very high temperatures, and then it will start evaporating more as compared to other one, and the wind speed is more, then also it will like evaporate very fast. Increase in the surface area increases the rate of evaporation. Obviously, like by this only you can understand that if you increase the surface area, the rate of evaporation will increase here. Okay, increase in the humidity decreases the rate of evaporation. Obviously, then like if you are decreasing the humidity, okay, then what will happen here? So like that evaporation will start decreasing. Okay, so I hope you understand all the topic that we have discussed here. Each and every point you got an idea what is evaporation, what is boiling, what is temperature, melting, fusions, everything you got an idea what are the state of matters we have. Okay, so be keep watching my videos so that you will understand more about this topic. Okay, so so that's it for this topic. Okay, so thank you.